Hey everyone, welcome back to my channel. Today I'm going to give a technical review over one of the papers I presented a few years ago at the Liquids-Rich Basins conference in 2017. It's covering production optimization for multi-phase flow. Before we get to the content, please be sure to like this video, subscribe so you can get more content in oil and gas and professional development topics, and please be sure to comment on the video below so I can incorporate your feedback into future videos. Please be sure to hit that notification bell when you subscribe because I upload every Friday and every Sunday. Every Friday is a professional development topic, and every Sunday is a technical review, such as this paper. I do have a special announcement to make in that next week I'll be out of town, so I'll be uploading my videos either earlier or a little bit later. So please be on the lookout of those videos relating to professional development and a technical review. Well, let's get to the content. Hey everyone, as I mentioned, I'll be presenting a paper that I presented at the Liquids-Rich Basins conference in 2017. It's covering production optimization in the Midland Basin through lateral phase, multi-phase flow simulation. This is some of the work that I did with University Lands and Texas Oil and Gas Institute. As an overview of the presentation, I'll give the objectives, the workflow, the setups for reservoir and flow simulation, cum production and EUR comparisons, and some conclusions from the study. I want to start off to whet the appetite for the lower Sprayberry shale and the Wolfcamp B reservoirs, and if you look at some of the lateral lengths in the oil EURs, you'll notice that this goes a large variety in the results when it comes to lateral length versus the oil EUR. Not necessarily a one-to-one relation, but there are a lot of other parameters that come into play when it comes to these, such as your completions, your stimulation practices, and also the vintage of these wells, as well as the artificial lift and the geology. Here's the data set of EUR ratios versus lateral length, where I did the EUR ratio or reference depth or normalized EUR at 7,500 feet, and I based it off of the lateral length, which is in the x-axis, and I have EUR ratios, which are in the y-axis. You'll notice that again, for the lower Sprayberry, it's all over the place. And for Wolfcamp B, this is the normalized depth and normalized EUR at 7,500 feet, compared to your lateral length and EUR ratios for the Wolfcamp B on university lands. Therefore, the objectives of the study was to determine optimal lateral length trajectories in the Midland Basin by studying the impact of lateral length and trajectory on well production performance. We developed a workflow that couples reservoir simulation with wellbore simulation, and we wanted to study the impact on cum production by lateral length trajectories in a low GLR reservoir and a high GLR reservoir. A low GLR reservoir is lower Sprayberry, and a high GLR reservoir is the Wolfcamp B. Here's the production optimization workflow that we used to work with, which is similar to the artificial lift best practices video, and I'll put that link in the description box. We collected data for QA/QC, built well performance models, then we calibrated a numerical simulation model, we had an RTA-based analytical model, or developed a type curve. We forecasted the PI over time, and we built wellbore models with different trajectories. We matched production with original wellbore design. We evaluated production outcomes with different time steps and kept the PI unit per length. We evaluated wellbore contributions for each trajectory, and if there were significant differences, we performed an economic analysis, and we'd recommend optimal wellbore construction with respect to reservoir performance. Some of the biggest takeaway messages that I'll mention up ahead of time is that the toe-up wellbore trajectory demonstrated the best oil and liquid production, regardless of the reservoir. Vertically undulated reservoir wellbores have the worst impact on recovery, and with doubling the original lateral length, the scaling well performance does depend on the GLR. So the lower Sprayberry, the EUR ratios averaged about 2, whereas the Wolfcamp B, or high GLR ratios, you didn't necessarily get a 1-to-1 scaling of lateral length. That was about 1.6. Again, this is on university lands. So here's the normalized oil EUR versus normalized lateral length, in that when we normalize the lateral length in the Wolfcamp B, I showed this before, where you're not getting that 1-to-1 ratio for the Wolfcamp B, but in the lower Sprayberry, you're getting that 1-to-1 ratio. But then again, this is some of the work that was done through simulation. Here's some of the candidates that we looked into detail. This is in Andrews County for the lower Sprayberry shale with the reservoir pressure of about 4,350 psi. The initial GOR was about 600 scuffs per barrel, and the initial GLR was 310 scuffs per barrel. So this is classified as a lower DLR well. For the Wolfcamp B, this was based in Erie County, where the reservoir pressure is a little bit lower. Your initial GOR is 1330 scuffs per barrel, and your initial GLR is twice compared to that of the lower Sprayberry. We calibrated reservoir simulation models. This is a slide that I wanted to show you on how we developed the full wellbore model. And here's the history match that we ended up doing for our particular lower Sprayberry well. The next I wanted to show is the main difference between conventional and unconventional reservoirs. In conventional reservoirs, your PI would be consistent over time, but in unconventional reservoirs, you'll notice that for the lower Sprayberry and for the Wolfcamp B, the PIs differ over time and is declining. We wanted to show you the wellbore flow simulation scenarios in that the original wellbore trajectory was relatively undulated but a little bit toe up. Then you had a flat wellbore trajectory just to normalize the undulation effects and how that impacted EUR. Then we had a toe up scenario where there's a TVD distance of 200 feet, a toe down scenario where there's a TVD distance of 200 feet. And then we had an undulated scenario where you had 200 feet for the entire amplitude, or not the entire amplitude, the entire height. Here's an example of wellbore flow simulation after the first month. Your bottom hole flow pressure does decline from your toe to your heel. And the inputs for each time step is you have your unit PI, your GOR, and your water cut. We also looked at reservoir pressure, pressure boundary conditions, which is at the top of the heel. The black represents your trajectory, the original trajectory, and the pink represents your wellbore pressure from your toe to your heel. The program that we use for this is Olga. Here's some of the liquid holdup that we wanted to emphasize on. Despite the minimal undulations that happened in the original trajectory, the liquid holdup is pretty significant when you look at throughout the wellbore trajectory. Liquid holdup is defined as the fraction of the liquid that is covering the surface or the cross-sectional area of the wellbore. So that's covered by the fraction. So if it's a 1, that means the liquid holdup is you have a cross-sectional area that's full of liquid. If you have something that's less than 1, that means you have a gap. Here's a wellbore flow simulation example at day 1 where you had some liquid holdup trajectory. We had some liquid holdup as you're reaching the toe. Your flowing bottom hole pressure does reach because you're accumulating liquid near the heel of the well. And here's the lower Sprayberry early time cumulative liquid production results. You'll notice that for each trajectory, we came up with 30, 60, 90, and 180-day cumulative production results. So liquid cumulative production ratios between longer and shorter laterals are consistent for production time of accumulation. This came for the original lateral length, and this is when we doubled the lateral length. Here are some of the production comparisons at 180 days. You'll notice that at the undulation results, they're significantly lower compared to your toe up, your flat, and your toe up and even your flat. The upper curves represent your 15,000 foot laterals. Your lower curves represent your 7,500 foot laterals. There wasn't too much of a difference between your undulation, and your other trajectory cases, but there is a significant difference at longer laterals. Here's some of the liquid rate cases after 30 years for the lower Sprayberry. You'll notice that there's minimal difference. Here's some of the EUR results for your 7,500 and your 3-mile laterals. What we've noticed here is that we compared this to the oil flat, or your percentage change of the flat case, and found that your toe up gave you the largest cumulative production, and your undulation case gave you your lowest cumulative production. The results were even emphasized in the 3-miler case, where the undulated case was the farthest away from the flat case, and your toe up had significantly better results in cumulative production and lower DLRs. So the toe up was the best performer either for both lateral lengths. Tortuosity could hinder well performance, but not to a dramatic extent. The cum DLR was about 520 scuffs per barrel when simulating the lower Sprayberry. If you look at the liquid ratio and the total EUR ratio, you're looking at about a 1-to-1 ratio when scaling up your lateral length, where the vertically undulated one, that actually decreases. Here's the Wolfcamp B EUR ratios, where the scaling was not 1-to-1, but the vertically undulated case exacerbates the problem of you're not going to scale up to 1-to-1. Again, it depends on where you are in the basin. The high GLRs in this formation could contribute to lower EUR ratios, and the reservoir pressure reaches bubble point. So some of the conclusions: this workflow and simulation determined the pressure decline along the lateral, implied wellbore contributions, and trajectory, elevation, and undulation effects on production rate and EUR. The impact on trajectories on production: the toe-up wellbore consistently results in best oil and liquid production for high and low GLR formations. The vertical undulated wellbore may have the worst impact on recovery. And depending on model trajectory, scaling well performance with doubled lateral length depends on GLR. For the lower Sprayberry, the oil cumulative production ranges from 1.8 to 1.98, and the Wolfcamp B oil cumulative production ratios range from 1.6 to 1.7. Trajectory could be a factor to historical pore fits between EUR and lateral length. So that's something to take into consideration. Definitely want to thank Schlumberger for the work and providing of the software, and then of course the Togi team have helped quite a bit, and we had additional domain expertise as well to help out with this work. And that's everything that I wanted to show you regarding this presentation. As usual, please be sure to like this video, subscribe so you can get more content in oil and gas and professional development topics, and please be sure to comment on the video below so I can incorporate your feedback into future videos. I appreciated you taking the time to watch this video, and I'll see you in the next one.